Next one is monoamine oxidase inhibitors. Monoamine oxidase inhibitors. So what does these drugs do? No? So drugs are chemical, whichever has amine in its structure. Whichever has amines in its structure, they get metabolized. Monoamine oxidase is an enzyme. See, for example, here you can see that this is an amine. This is an amine. So this is, for example, adrenaline. You consider adrenaline. CH2, sorry, CH, OH, CH2, N, H, CH3. This is amine. Okay. Now, whenever a chemical, for example, you see serotonin, that is 5-HT. 5-HT, noradrenaline, adrenaline, even dopamine. They all have one amino group in its structure. How many amine? Only one amine. So all have, what is common in this all neurotransmitter? Having one amine in its structure. So they have one amine. So this enzyme will metabolize that amine groups here. It removes that amine. So where does this amine group go? Here you see. Here it breaks, converting this carbon as keto group. So that's why it is called as monoamine oxidase. Monoamine oxidase. So how does it come? Let me draw the structure. This. So now you can see it. It will become benzene. It will become OH will be acid, CH, OH. Now this will become aldehyde or ketone. So like this it will form. So all these neurotransmitters such as 5-HT, norepinephrine, adrenaline, dopamine, they consist of one amino group in its structure, and this enzyme metabolizes. So deamination plus oxidation. It is doing two factors: removal of amino group and also creating oxygen. So that's why it is called as monoamine oxidase. In our disease, the levels of these neurotransmitters decrease. Now our drugs prevent this metabolism. So what happens? The levels of these neurotransmitters are increased. So this is the mechanism of action of these drugs. For example, here you see, this is a synaptic vesicle, presynaptic now. When you receive the signal, what happens is that neurotransmitters are released. But for some people, what happens is that for unknown reason, the neurotransmitters will enter mitochondria and get metabolized by MAO. You can see it. 3 neurotransmitters are present here. 2 are released. 1 is getting metabolized. Only one drug is able to bind to the receptor. Now, when you see here, when you see here, what happens when you give MAO inhibitors? it is blocked. The MAO enzyme is blocked, and all the neurotransmitters are going to the in the synapse, and they're binding to the receptor. So this is, you see, normal monotransmission. This is effective MAO inhibitor. This is the mechanism of action of these drugs. Now, in this slide, you can see that's what we told. See here. MAO is a mitochondrial enzyme involved in oxidative deamination. I told you what it does. Oxidation plus deamination, or deamination oxidation, like adrenaline, noradrenaline, dopamine, 5-HT. So this is it. So what is main important? If this is causing disease, what is the main use? Why did God create MAO? God created MAO to maintain these levels. If these levels are becoming excess, we get hypertension. We may die also. So that's why God has created MAO. So whenever their levels are very high, when their levels are very high, the MAO will come and metabolize these neurotransmitters. And one more very important thing is that this MAO is very, very, very important. Some of the chemicals which are present in our food also consist of amines. So for example, you see, also inactivates potential toxic amines present in our food. MAO will also, one is to decrease the neurotransmitter levels in our body whenever they become excess. Another one is that to decrease the toxic effects of amines present in our food. What are those amines? Tyramine, phenylethylamine, benzylamine. These are the toxic amines present in our chocolates, cola, soya beans, meat, grapes. These are toxic amines. So these amines gets metabolized by this enzyme, MAO. So what are the two functions of MAO? Number one function is inactivation. Another one is inactivates potential toxic amines. Potential toxic amines. So these are the two main functions. But in depressed patient, what happened? The levels of MAO is excess. So it inhibits the neurotransmitters. So now when you give these drugs, will act. Now, one more important thing is that MAO is two types. MAO enzyme is two types. MAO A, MAO B. MAO A deaminates and oxidates even 5-HT noradrenaline. These two neurotransmitters. MAO B deaminates dopamine. Now, MAO A is present in autonomic nervous system, intestine, placenta. MAO B is present in brain and platelets. And also remember that last class we studied decreased dopamine levels causes Parkinsonism. So which enzyme, which MAO is acting on dopamine? MAO B. So MAO B drugs are used in treatment of Parkinsonism disease. Parkinsonism disease. The liver contains both MAO A and MAO B. So this is some information about MAO. So let me clearly tell. What does MAO means? Monoamine Oxidase enzyme. The main function of MAO is that it metabolizes neurotransmitters which contains single amine. Example, adrenaline, noradrenaline, dopamine, 5-HT. So that is, whenever these levels are excess, our body will produce MAO. It is a mitochondrial enzyme. So it inactivates this so that the levels will be normal. One more important function is that our food consists of these toxic amines such as tyramine, phenylethylamine, benzylamine. So these levels these are very toxic. So the levels increases and causes toxic effects to us. So that also it inhibits. Then one more important point what we studied, they have two types of MAO, MAO A, MAO B. MAO A specifically metabolize 5-HT and norepinephrine. MAO B specifically metabolize dopamine. So this is an next one is, so these are our drugs, you see, tranylcypromine. So our drugs also consist, you see here, this is our natural. Let me, now this is our natural norepinephrine, this is single amine. Now our drugs consist of single amine. So these drugs get metabolized instead of noradrenaline. So tranylcypromine, see this is tricyclic. Tranylcypromine, this is salicylin, which is a MAO B inhibitor used in Parkinsonism, not for depression. Why? Because MAO B is metabolizing only dopamine. Phenelzine. So this is the hydrazine structure. Hydrazine means a chemical consisting of NH, NH2. So this is phenelzine. So these are the drugs which act this. Now, here you see these are the side uses. Then one important thing is that when you are dispensing these drugs, ask the patient not to take all these food materials because it prevents its second activity. I was telling second function of MAO is that toxic metabolites present in our food will not get metabolized. So these are the toxic these amines like meat, beans, this banana, grapes, pizza, spinach, beer, meat. All these consist of these primary amines like tyramine. So they will not be metabolized if you take along with these drugs. So there is food-drug interaction. So tyramine-rich foods like cheese, red wine, beer, chicken liver causes cheese-like reaction. What is that? They will not inactivate tyramine. So the levels of these amines will get increased. They produce, see, when tyramine is increased, what happens? They in turn produce catecholamines. What are those catecholamines? Adrenaline, noradrenaline, dopamine. And causes tachycardia, headache, arrhythmias. So if not treated, if you combine them, even they get stroke after eating food, they may die within 30 minutes to 1 month. So very dangerous. So if you are dispensing these drugs, you need to educate the patient, telling that not to eat this food. What is the antidote? By mistake, they taken. What's an antidote? Pentolamine and prozosine. These are the two drugs which are alpha alpha 2 agonists, which are used. Alpha 2 antagonists, sorry. Alpha antagonists, alpha adrenergic antagonists, which are used in treatment of this. Okay, we will stop here. Any doubt, please? Last one class. Two drugs are there. Can we finish this and go? Only okay, we will stop here.